course, this question requires spherical integration. And this one's pretty similar to what we've done before. Last time we had something like uh, x squared plus y squared, or maybe we had a 3, but this was a cone, right? So it's the cone that's up this way, right? So what happens if you divide by 3? Well, it'll still be a cone, but to see what this 3 does, you want to take the xz trace, which means you set y as 0, and that gives you z equals the square root of x squared over 3, which is, did you know that the squares and square roots don't really cancel when x is negative? These two simplifies to absolute value of x over square root of 3. Did you know that? No? What's this? Okay, yeah. See, if x is negative, then negative 1 squared square root is square root of positive 1, which is 1. So this is same as the absolute value of negative 1. So when you cancel the square root and square, it doesn't really cancel completely. Rather, it gives you this. Okay. All right. So what this means is you have a V-shaped thing, right? V-shaped thing, and at least when x is positive, absolute value of x is same as just x, right? So you get this equation, z equals to x over square root of 3. So this one right here has a slope of 1 over square root of 3. That's the slope. In other words, if x is square root of 3, then plugging that in, then z becomes just 1, right? So having 1 over square root of 3 as a slope means that when you're at square root of 3, the height just becomes 1, so that this length is 1 and this length is square root of 3. And I'm again trying to use our previous experience. We needed not this angle, but the angle from the top, right? Yeah, because that was the phi that we needed. Okay? So that was the phi. So we need this angle. So this angle is phi, but that's congruent to this angle. Okay? So to get what that angle is, well, some might already recognize this as a 30, 60, 90 triangle that has 1 square root of 3 and 2. But if you don't, then you can easily see that tangent of phi is opposite over adjacent, which is square root of 3 over 1. And putting your calculator into degree mode and doing tangent inverse of, this is a square root of 3, so if you do square root of 3, you see right away that this angle is 60 degrees. Okay? And 60 degrees is the same as pi over 3, so that means the top comes down from 0 degrees to pi over 3. This angle will be pi over 3 degrees. Okay? All right, so that was the explanation that says that phi should be between 0 through pi over 3. Okay. All right. Now, what would you get if you overlaid this one on this picture by also taking the xz trace for this one? So, what is the xz trace of x squared plus y squared plus z squared equals to 36. Well, that's going to be x squared plus z squared equals to 36, which is a circle of radius, what? Circle of radius? 6. So what you're getting is, here's your cone, right? So remember, this is just the xz trace, but if you had the y-axis will be the one that's going into the board, but anyways, it's going to be a cone like this, right? It's a cone like that. And above it, there's the there's a circle of radius 6 above it, okay? And the volume that we're trying to get is this three-dimensional object, okay? It's a bit hard to draw in three dimensions, but if I try my best, it's something like this. So you have a cone downstairs, and you have something like that, and the question is, what is the volume of this object? Okay. Okay. So, and then what about theta? What will be the bounds for the theta? Well, this is you go in full circle, right? So theta will be from what to what?
0 to 2.
Yeah. And we also, I also explained last time that the volume is to simply integrate 1 over this domain, and then you get the volume, right? So what we need is now, volume is, you're integrating 1, and then you're doing 1 dV, but dV is, in spherical coordinate system, is rho squared sine phi d rho d theta d phi, where rho is trying to fill this space radially coming out from the origin. So it starts from 0. Where does it end? Where does it end?
0 to 6.
6, right? So rho equals to 6. A spherical coordinate system just gives you the sphere of radius 6. So if you have any kind of integral that has spheres in them, then it makes sense to use the spherical coordinate system, okay? So we're going to put rho from 0 to 6, theta goes from 0 to 2 pi, and also we said phi goes from 0 through pi over 3. Okay, so let's continue on. Since 1 sine phi, these are constants when you're integrating by rho, you're just really integrating rho squared. Yes?
So, I'm sorry.
Yeah.
How do we integrate to 1 dV with the volume? Is it always the 1?
Yeah. So to get the volume, so what I'm trying to say is that V is sum of small parts of V.
Okay.
That mass is the sum of small parts of mass. Okay? And later on, you're going to learn that there's some other quantities that's additive like this. So
Okay.
some of you are taking physics 2 right now, and you've learned flux, right? Flux also has this property. If you want to get the total flux, you integrate the small bits of flux. And that's exactly what you've been doing in some of your physics 2 exam questions. So this is always true for any physical quantity that's additive, right? If you can add some small stuff and you get the big thing, you can always do that. So what I'm doing is I'm taking V and writing it as sum of small d. But dV is in rectangular coordinates, it's dz, dy, dx. In spherical coordinates system, you need this extra factor, right? I've explained why this happens. So now that we have to integrate rho squared, that's 0 to pi over 3, 0 to 2 pi. Integral of rho squared is 1/3 rho cubed. Sine phi is just a constant multiple, so that doesn't change. Times 1 doesn't do anything, so I'm not going to write that either. Oh, and I forgot. You have to plug in 6 and 0. And these values go into rho, not to phi, because we've integrated to rho. 6 times 6 times 6 is 216, and we divide, you get 72. Okay, so you get 0 to pi over 3, 0 to 2 pi of 72 sine phi, d theta, d phi. And now let's continue over here. Oh, well, this doesn't have any theta at all. So if you integrate this by theta, it's just integrating a constant. It's like integrating 1. 1 integrates to theta itself, right? So this one's going to become 72 sine phi. These are just constants, and theta gets multiplied, and you plug in 2 pi and 0. You still need to integrate by d phi. D phi goes from 0 to pi over 3. When 2 pi is plugged in, 2 times 72 is 144. Now you're almost there. Sine phi integrates to what? Negative cosine phi, right? And then you plug in pi over 3 and 0.
Oh, what'd you plug in 2 pi to?
2 pi goes into theta, right?
Oh, okay.
Oh, sorry.
Is there pi?
Good catch. So there's a pi there. I only multiplied by 2 and forgot the pi.
Oh, okay.
All right, so there's 144 pi. So 144 pi. And then when pi over 3 is plugged in, well, let's first write down what I'm supposed to do. Should be this one, and minus negative cosine of 0. Okay. Who can tell me the value of cosine pi over 3?
-1/2.
Okay, so including this negative, cosine pi over 3 itself is 1/2, so including this negative, it will be -1/2. Minus minus becomes
1.
plus. What's cosine 0?
1.
1. So 1 plus -1/2 is 1/2. 1/2 times this will be 72 pi. That's the answer.